Just going to open the file. I want to play it real quick for you, and then I'll take it in. So look at what's happening. This ball is being fired into this piece of PVC. I call this a ballistic pendulum. And so as it's fired into this PVC, the ball has all of the momentum, okay? And it's transferring it to the PVC, all right? Or to the ballistic pendulum. The ballistic pendulum doesn't have any momentum because it's at rest, all right? If you look at it, when you fire, before the ball is fired, it is at rest, okay? So stop. See, it's at rest. So remember, we define momentum as mass times velocity. Cool beans? Now that's the idea. I'm just gonna go ahead and share this with video physics. And while that goes into video physics, you'll see that we can rewrite this equation. The momentum, the initial momentum in the x direction is just the mass, and I'm not going to even use the x direction. I'm just going to say the initial momentum. I'm going to go to a generalized formula. Is equal to the final momentum. And so we start off with the mass of the ball, which is the little ball coming out of the mini launcher, times the velocity of the ball. We're going to calculate this velocity, this initial velocity, plus the mass of the tube, which is the ballistic pendulum, times the velocity of the tube. All of this is in the initial state, equals to the mass of the ball times the final velocity of the ball, plus the mass of the tube times the final velocity of the tube. Now, the reason why I'm writing both of these as final velocity is because both the ball and the tube should be moving synchronously. They should be moving the same. The idea is that the ball is in the clay, okay? And so this is our final scenario. If we analyze this, we basically are looking at the ball with some velocity that we want to calculate. Some velocity that we want to calculate. There's some clay back here. The tube has some mass. The ball has some mass as well. And the tube has some velocity. In this particular case, it's 0 meters per second. The goal of this experiment is to calculate the initial velocity of the ball. And we're going to use the conservation of momentum and the conservation of energy to do this. So once the ball strikes the clay, the tube begins to move. And we're going to look at the tube when the ball is embedded in the clay. It's actually going to be working itself into the clay and moving and all of that stuff. So this is going to be our final velocity. It shouldn't be so much greater than the initial velocity, but this is going to be our final velocity here. Now, we don't know this as of yet, but we plan to. So if I rewrite our equation, mass of the ball times the velocity of the ball plus the mass of the tube times the velocity of the tube, in the initial condition, we end up with this is equal to the mass of the ball times the final velocity. Instead of me writing all of that, mass of the ball plus the mass of the tube, we can factor this out, times the velocity, okay, of both the ball and the tube. So this piece is going to go to 0 because the velocity of the tube in the initial condition is 0. So we end up with the mass of the ball times the velocity of the ball equals to the mass of the ball plus mass of the tube, sum of those times the velocity, the final velocity of the ball. So we're looking for our velocity here of the ball. And we do have something to compare it to because we've done this several times in several different ways. It's just exploring a law, a new law in a different way.